Let's first define the angle of elevation and the angle of depression. The angle of elevation is the angle created by the ground and the line of sight to an object above the ground. So the angle of elevation is the angle formed by the horizontal ground and the diagonal line of sight. The angle of depression is formed by the line parallel to the ground looking straight out from a spot above the ground and the line of sight to an object down below. So the angle of depression is looking straight out and then down. It's the angle created by the line parallel to the ground and the line of sight to an object below. And since the ground and the line parallel to the ground are parallel, our angle of depression and angle of elevation will be congruent because they're alternate interior angles. So let's apply the angle of depression and angle of elevation to answer some word problems. In example 1, a person is standing in a treehouse. There's my tree. There's my treehouse. And there's my person in the treehouse. And they notice a squirrel on the ground. So I'm going to draw in my ground, and I'm going to draw in my squirrel. The angle of depression from the person in the treehouse to the ground is 55 degrees. So the angle of depression is the angle created by the line parallel with the ground and the line of sight to the object below to the ground. So the angle of depression is this angle right here, 55 degrees. The direct distance from the person to the squirrel is 15 feet. Well, the direct distance will be the distance from here to here, going directly from the person to the squirrel. That's different than ground distance, or that's different from height above the ground. The question is, how tall is the treehouse? Well, that distance will be this distance right here, x. And if you notice, that distance, that height, creates a right angle with the ground. So this problem is really a right triangle problem, where the hypotenuse of the right triangle is 15 feet. But now we need to figure out an angle in this triangle. Well, if you remember, my angle of depression and my angle of elevation will be congruent to each other because they're alternate interior angles. So this angle will also be 55 degrees. And since I know that this angle is 55 degrees, x is going to be opposite that angle. So I know one angle, I know one side, and I need to solve for a side. That means I want to do trig. And I know the hypotenuse, and I want to solve for the opposite side. So that tells me opposite hypotenuse, I want to use sine. So sine of my angle equals the opposite side over the hypotenuse. Now I need to solve for x. Turn my ratio into a proportion and cross multiply. 15 times the sine of 55 degrees equals x, which means that x equals 15 times the sine of 55 degrees. and I can use my calculator to approximate that answer. 15 times the sine of 55 degrees is about 12.3 feet, which makes sense in a problem like this. If this distance is 15, that would make sense that the treehouse is about 12.3 feet above the ground. Let's look at example 2. A kite is flying 20 feet above the ground. So I'm going to draw my kite. With its little tail. "20 feet above the ground." Well, here's the ground. So 20 feet above the ground is going to be the distance straight down, creating my 90-degree angle with the ground. So this is 20 feet. The ground distance from the kite to the person flying the kite is 30 feet. So the ground distance is the distance on the ground. So this distance is going to be 30 feet. What is the angle of elevation to the kite? Well, the angle of elevation is created by the ground and the line of sight to the object above the ground. So the angle of elevation is going to be this angle right here. So I'm going to call that angle x. X in this case is my unknown. And if I look, I have a right triangle. Hypotenuse, opposite, adjacent. Well, I know the opposite side and I know the adjacent side. So if I want to solve for x, if I want to solve for this angle, I'm going to want to use tangent. Tangent will be opposite over adjacent. So tangent of my angle equals opposite over adjacent. Now, to solve for x, I need to undo what's happening to x. In this case, x is being tangented. I need to do the inverse tangent of both sides. (20 over 30) can be simplified down to 2/3. Tangent inverse of tangent undo each other, so I'm left with x equals the tangent inverse of 2/3. Again, I can use my calculator to approximate that answer. Tangent inverse, second tangent, of 2/3 equals 33.7. So x is approximately 33.7 degrees.